Sorry I couldn't be with you next couple weeks, but I'm at home enjoying my new baby boy, as you can see here. There's my little baby boy Jace Michael Swinger, and my two girls there, seeing them for the first time. So hope you guys are doing okay. Hope you did okay on that quiz. What we're going to do for the next couple weeks while I'm not there is we're just going to cover a few sections. So today's section 6.3. You already covered section 6.6 with Mr. Puff. And so we'll just be doing basically 6.3, 6.4, 6.5 with a podcast. And I'll tell you all you need to know. Don't be worried, I'm going to throw too hard of problems on there, but everything will be on the podcast that I test on. So you'll have a test right before I get back. So I put up a schedule. Check out the calendar on my website, and you guys should be okay. So work in groups. Do everything you can to do well. Don't treat all this stuff lightly. So take some good notes today. Alright, here we go. Section 3, composition of functions. I'm going to go through about 5 examples here. And the first one is f of x equals 4x to 1/2 and g of x is negative 9x to 1/2. Find f of x plus g of x. So I just take f plus g, get an easy answer. What I'm going to do is the hard part of this question. The next part of this question is going to ask about domain. So we're going to go revisit that right now. So I made up some of my own problems for finding domain. Write this down. This is what people miss the most right here. How do you find domain of all these weird looking functions? So number 1, how do you find domain of negative 8x to the 1/2 power? Well, what I like to do is I like to say, okay, what does x to the 1/2 mean? The negative 8 doesn't matter. What domain is, in simple terms, is, what could x be? Right? When you think domain, you think of x. So what could x be right here? That's what domain means. What could x be? So could x be any number? Yes, no? I like to look at a number line to figure this out. An easy way to do this, the easy problems is, I ask myself this question, could x be any of these negative numbers and beyond? Could x be 0? Or could x be positive? That's what I ask myself. What does x to the 1/2 means? I like to do this and say, okay, that really means the square root of x to the 1/2 power, right? So, could x be positive? The square root of a positive number. Throw anything in there. 5, 9. Could x be positive? Yes. Check. Could x be 0? Square root of 0. Is that an answer? Yes, it's 0. Square root of 9, 3. Could x be negative? Right there. Pick any negative number. Square root of negative 4. That is an imaginary number. You can't have the square root of a negative number. So therefore, x cannot be negative. So I kind of X that out and say, well, what could x be then? If it can't be negative, it could be 0, could be positive. So if you want to write it like this, you could say x is greater or equal to 0. You could write domain like this. Or what does this really mean? From here on, right? So also the book says all non-negative numbers. Okay, that's the same thing. Greater than or equal to 0, all non-negative numbers. Okay, so know both of those actually. Alright, next one, number 2. So here's the question to ask yourself. If I say find the domain, you should think, okay, what could x be? Well, better yet, I like to ask myself, what couldn't x be? So look at this right here. Disregard the 3 out front, doesn't matter. X to the 1/3, what does that mean to you? That means the third root of x. So I ask myself a question again. Could x be positive? Yes. The cube root of 8. That's 2. Good. 0. Could x be 0? Cube root of 0. Yes, that's 0. Cube root 0. equals 0. Good. Could x be negative? Well, let's try it. Cube root of negative whatever you want over here. Negative 8. It's cube root of negative 8. Does that have a real answer? Yes, it is negative 2. So it could be negative, right? Could be negative, could be 0, could be positive. So what do you say for the domain of this thing right here? X could be anything, right? Anything negative, anything positive, 0 even. Could be all numbers. So you have to say this. All real numbers. All real. There you go. Alright, example 2 done. Ask yourself, what couldn't x be? So that you can tell yourself what x really could be. X could be everything, all real numbers. X could be greater than or equal to 0. Okay? X couldn't be less than 0. So, here we go. All real numbers for number 2. Number 3, look at this one. A little different. X to the 3/4 power. I just need to look at this right here. Well, I like to look at it like this, and it might help people. 4th root of x to the 3rd. Inside, or you could put it outside. The 4th root of x. So, or you could look at it, oops, like this. 4th root of x to the 3rd. Doesn't matter. So, 4th root of x. Look at that one right there. It's probably easier to look at this one. Could x be, once again, could x be positive? The 4th root of 16. Yeah. That's 2. The 4th root of, could x be 0 in this case? 4th root of 0? Yeah, that answer is 0. Or lastly, could x be any negative number? The 4th root of negative 16. What's the 4th root of negative 16? That's an imaginary number. You can't do the 4th root of negative 16. Remember one of those, maybe it was lesson 6.2, it talked about the index. If the index is even, these numbers inside the radical have to be positive, right? Or there's no real answer to it. Just like square root. You can't have a square root of negative 4. That'd be an imaginary number. You can't have the 4th root of a negative number. That's an imaginary number. So therefore, look what we have here. X can't be negative. X could be 0. X could be positive. So everything from here, the whole way over. So once again, this is x is greater or equal to 0. Or you could say all non-negative numbers. Okay? That's how you find domain. Now pay attention to this. This is what people miss the most. I told you that in the beginning. That's why I'm kind of taking my time to do this. Here we go. What if it's like this? X to the 3/2. I like to write it like this. The square root. There's 2 index. And I'll put the 3 out here. I'll tell you this right here. The top number doesn't matter for domain. Like whatever that top number is, it doesn't matter. Okay? 1, 2, that could be 7/3. Doesn't matter. All that matters is the index down here. 3 here, 3 here. If it's the cube root, x could be anything. Negative, 0, positive. If it's an even root, 2. 2, 4. This is what? This is 2. Even root. X can't be what? If it's an even root. X can't have a negative in here, right? If you have the square root of negative whatever, negative 4, negative 8, negative 16, it's going to be an imaginary number. So x cannot be negative. I kind of X that out. Alright, x can't be negative. Could x be 0 here? Yeah, square root of 0. 0. X could be 0. Could it be positive? Square root of 4. Yes. Good. Could be 0 and above. Once again, the answer is x greater than or equal to 0. All non-negative numbers. There you go. Little lesson on finding domain. Alright guys, back to example 1. You just find out how to figure out the domain. Right? I told you how to do that. Now let's apply it to some of these functions here. Let's do f of x plus g of x. All you do, take f of x, which is, I told you, right here. Put this right here, substitute. Take g of x, which is this, put it right here, substitute. What is this plus this? Well, it might look weird, but these both have x to the 1/2. So that's like 4x plus negative 9x. That'd be 4 plus negative 9, negative 5, x to the 1/2, right? That's simple. That's going to get you a couple points there. The harder part's coming. So f plus g, negative 5x to the 1/2. Notice the exponent does not change. X to the 1/2 plus x to the 1/2 does not change this. Now, next one. What is f of x minus g of x? Same thing. Plug it in. This minus this. 4 minus negative 9x to the 1/2 becomes 13x to the 1/2. Now, so you all understand how to get this. We're just adding and subtracting functions, okay? Let's look at this. It says, what are the domains for f plus g and f minus g? Well, f plus g was equal to what? What was it? 9? I forgot already. F plus g. Negative 5x to the 1/2. Okay? Well, to find domain, you actually have to look at them individually. A lot of times, here's where people mess up. A lot of people will say, okay, f plus g is equal to negative 5x to the 1/2. Oh, what is the domain of negative 5x to the 1/2? Or negative 5 square root of x? Well, x can't be negative here, so the domain is x is greater or equal to 0. Alright? Everything greater or equal to 0. That's the domain of this right here. But really what you have to do is you have to go back to the beginning and say, okay, what is the domain of f? Now look at it, x to the 1/2. That is this. What's the domain of g? Same thing. And luckily in this case, you wouldn't get anything wrong. You'd say, okay, the domain of negative 5x to 1/2, the domain of f plus g is x is greater than or equal to 0. Look at letter B. It's going to say, what are the domain is of f of x minus g of x? Well, a lot of people will look at the end result, but I'm telling you, you have to look at the beginning. Look at f. What's the domain of f? We already said this. X is greater or equal to 0. What's the domain of g? Same thing. So what's the domain of f minus g? That's going to be the same thing because this is an easy problem. It's the same thing. But please, mark my words, always check the beginning. What are the domains in the beginning? Not just checking this, please. Alright, so domain of this, f minus g is this. Domain of this, f plus g is the same thing, x greater than or equal to 0. Now, the book is also going to tell you all non-negative real numbers, right? That means it starts at 0 and it keeps on going in the positive direction. This means all non-negative. 0 and beyond. Okay? So, learn those two things. Write that down. All non-negative. Alright, so we found f plus g and f minus g. Let's look at the solution. All non-negative real numbers. Meaning this. X greater than or equal to 0. Okay? So, that's example 1. Know how to add and subtract, which is the easy part. And then know how to find domains. Key is always look at individually. Look at f, what's domain? Look at g, what's domain? And then you could look at the result to kind of put it all together. You'll see what I mean in a little bit. In example 2, this might be something different. Watch. Now it's going to go through multiplying and dividing. Right? We just did add and subtracting. Now we're going to do multiplying. What is f of x times g of x? Well, you plug it in. 6x times, what's g? X to the 3/4 power. Okay, this times this, know your rules. X times x. So if they have the same base, you add the exponents. 1 plus 3/4. 1 plus 3/4 is, don't write 1 and 3/4. This is 6 times 1 is 6. X times x to the 3/4 is, 1 and 3/4 is the same as 7/4. So, oops, not a negative, sorry. X to the 7/4 power. And if you need to do this, do it in your calculator. Just type in 1 plus 3/4 math frac. It'll tell you 7/4. Okay, learn how to use that calculator, but don't rely on it. Okay. Let's see. 6x to the 7/4 is your final answer. You're done. Letter B. You're going to divide. Okay, you see how they do it on there? Alright. B is division. F of x divided by g of x. So let's plug it in. Let's substitute. F of x is 6x over g of x is x to the 3/4. Once again, use your rules, which makes 6 over 1 is 6. X to the first over x to the 3/4. 1 minus 3/4 is x to the 1/4. Okay? There you go. That's the easy part. Finding out what f times g is and f divided by g is equal to. Now you're going to do the domain, and here is where it's different. So please pay attention to this. Here we go. This one. The domains, f times g. So let's kind of rewrite it. F was, I think, 6x times g, which was x to the 3/4. Okay? There's f times g. And you told me, or we said, that it equals 6x to the 7/4. Now, if you ever want to find the domain, you have to ask yourself a question. A couple questions. Could it be negative? Could it be 0? Or could it be positive? Could x be negative? Look at this. Look at this one right here. Once again, you go back to the original. See this original part? Here's f. Go back to f. What's the domain of f? What could x be? Just right here. X could be negative, right? 6 times negative 5. That's negative 30. X could be negative. Could x be 0? Yes, right here. Could x be positive? Yes. X could be anything right here. So the domain of f, this guy, is actually all real by itself. It's all real. What about this? What about the domain of g? Domain of g, x to the 3/4. If you need to rewrite it, do so. Domain of g. Well, we did this on another question, right? We did this in the beginning. X to the 3/4 is the same as the 4th root of x to the 3rd power. Once again, what could x be? Or better yet, what couldn't x be? Could x be positive right here? Yes, if x was 8, yeah. Whatever. If x, could x be 0 in here? 4th root of 0? Yes, that's a real number. That's answer is 0. Could x be negative right here? The 4th root of negative 8 or negative 16. That is an imaginary number, so you can't have the 4th root of a negative number. So x cannot be negative, which means the domain of g, just this thing right here, is x has to be greater or equal to 0. It can't be negative. That's why I said x is greater or equal to 0. I'd like shade this. Remember shading? Alright, now look at the domain of f. All real numbers by itself. Domain of g, greater or equal to 0. So all real numbers won't work in this right here. Okay? So you kind of got to put both of these together and say, okay, the first one is all real. So I'd like shade this whole thing. But if I put these together, x has to be greater or equal to 0. So x really can only be this right here. From here over. It can't be this. Okay? Now I look at the final product and say, what about that? Is that the same answer? Just these? Greater or equal to 0? Let's check it out. What does that mean? X to the 7/4. 4th root of x to the 7th power. 4th root of, yeah, you can't have negative here. You could have 0. You could have positive. Can't have negative. So yeah, this is your answer. From 0. Could be 0 and it could be positive. So your answer for the domain of f times g, this is f times g, so domain of f times g is equal to, not equal to, but x is greater or equal to 0. There you go. Not too bad, but once again, look at the originals to find out this answer right here. Don't look at the final product. You'll see what I mean right now. We're going to do right now, what about f divided by g? I'm going to erase this. F divided by g, here we go. So what's f? 6x divided by g, which was x to the 3/4. Okay, our answer we said was 6x to the 1/4. Now for the people that try to do domain just by looking at this, watch what happens to them. Okay, if I said what is the domain of this, which is f divided by g, what is domain? You would say, okay, 6/4 root of x. X can't be negative, right? Could x be positive? Yes. Could x be 0? Yes. X can't be negative, so my answer is x is greater or equal to 0. That's my answer. If you were just looking at this, this would be true, right? But you have to take into account this is division, correct? Look at this right here. You always look at the beginning thing that you write down. Please mark that down. Look at the beginning. What could x be right here? Right here, x could be anything. That's 6x. X could be anything. But right here, look at this. Pay attention to this. Whenever you get fractions, here's where it gets more difficult. What could x be or not be right here? You seeing this? What does it mean? The 4th root of x cubed, right? X can't be negative, right? But x can't be something else. X cannot equal a negative number. But x cannot equal something else too. X cannot equal 0. You guys know why? Look at it. Because it's division. What if x was 0 right now? You'd have 6 times 0 over 0. You can never divide by 0. That's a no-no in math. You guys know that. So therefore, x cannot be negative and x cannot be 0. So what else do you have left? What could x be then? If x can't be 0 and x can't be negative, all you have left is positive numbers. So my answer to this question, the domain of f divided by g, is x is greater than 0. That's your final answer. See, this answer doesn't apply. If you just looked at this, you would get this answer, which you're wrong. But if you look in the beginning, what could or couldn't x be in the beginning? It leads you to this answer. X has to be greater than 0. Because if it was 0, you'd be dividing by 0, which cannot happen. Okay. That's the tricky part to dividing functions, finding domain. Circle this answer. Star it. I'm going to give you something like this. Okay? Get rid of that answer. Always look at the beginning. Can't stress that enough. Okay, that's it for example 2.